Below City News.
You're watching live on Below City News, where every news has its own velocity to deliver lessons and informations. With Jonathan Zambas and Jetro Lama. It's time for South 360. A football game is such a physically demanding activity since it requires a lot of energy to move a mile and quarter at most. This quarterback only has one goal, to go as far and as fast as he can down the field. The other team's defensive players will attempt to tackle him in order to stop him. Is the quarterback going to make it all the way to the end zone and score a touchdown? Newton's first law of motion is related into this matter. Jonathan Zambas and Jetro Lama will take a lead to introduce in you the Newton's first law of motion.
Newton's first law of motion asserts that until an unbalanced force occurs on an item, its motion will not alter unless acted upon by imbalanced force. An item at the rest will remain at the rest, and an object in motion will continue to move in the same direction, at the same speed. In football, Newton's first law is throwing when a quarterback pushes the ball ahead and then lets go to the ball wants to keep traveling forward. The more force he applies to the ball, the greater its inertia and the greater the mass of the football. The more force must be applied to it. In the photo, the football player is an action unless the opposing team's player provide an imbalanced force against him. He will remain in motion. Retro will display.
Thank you, Zambas. Newton's first law says that if the net force on an object is zero, then that object will have a zero acceleration. That doesn't necessarily mean that the object is at rest, but it means that the velocity is constant. There are two conditions on which the first law of motion is dependent. Object at rest. When an object is at rest, velocity and acceleration are zero. Therefore, the object continues to be at rest. Object in motion. Velocity is not equal to zero, while acceleration is equal to zero. Therefore, the object will continue to be in motion with constant velocity and in the same direction. Back to you, Reza.
Thus, objects that rest will continue to rest and objects that move will continue to move unless they are influenced by some outside force. And that's all for today in Below City News. Thank you.
Hello everyone, my name is Mark Caviles, and for today's video we would like to present Newton's second law of motion and its formulas. And I'm with my brothers, Darwin Taha and Christian Fajardo. But before that, I want you all to smash the like button and subscribe and click the notification bell to be notified on our next video. Newton's second law of motion says that the greater the mass of an object being accelerated, the greater the amount of force needed to accelerate the object.
So, this is how we do it. Try to apply a little bit of force to the object. Now, try to apply more force to the object. So you see, the speed increases when you apply more force to the object. Unlike our first attempt, it really has a huge difference between applying force to the object. Now, let's proceed to the formula. Newton's second law of motion, where F is force, M is mass of the body, A is acceleration of the body. First is, the formula will be F equals to ma. Now, let's proceed on how to solve Newton's second law of motion.
Hi everyone, I am Darwin Tahat, and here's the example. An object with a mass of 3 kilograms accelerates at a rate of 4 meters per second squared. What is the amount of force applied on it? So let's identify the given. For mass, we have 3 kilograms. And for acceleration, we have 4 meters per second squared. In this example, we are looking for the amount of force. And the formula in solving for the amount of force is mass times the acceleration. So we have 3 kilograms multiplied by 4 meters per second squared. And we have 12 meters. Let me go to example number 2. How much force is applied to one object with a mass of 10 kilograms and accelerates at a rate of 3 meters per second? Let's identify the force. So for the mass, we have 10 kilograms. And for acceleration, we have 3 meters per second squared. Still, we are looking at the multiple. Same steps are applied by multiplying the mass and acceleration. So for the mass, we have 10 kilograms multiplied by 3 meters per second squared. And we have 30 newtons.
That is how you solve Newton's second law of motion.
Thank you guys for watching. Hope you all enjoyed the video and see you soon for the next video. Peace out.
EJ,
Hey Jock, what's up?
I saw you lately. Is there something troubling in your mind?
Yes, we have a performance task and it involves 3 of Newton's law of motion.
Oh, that's right. I have little knowledge about it.
Really? Well, can you help me out and please explain it to me in order for me to accomplish my task? Because I didn't get clearly what our teacher thought earlier. I'm lacking, bro.
Yes, of course. Last week, our teacher shows us a blog on how the first law of motion being applied. They said that the object continues to do what they're doing unless some unbalanced forces act.
Unbalanced force?
Did you see that ball? The ball didn't move, right? That's because there is no unbalanced force.
Ah, I get it. So the ball is blown away by the wind, therefore the wind is the unbalanced force.
Exactly, and that is one of the 3 laws of motion. And always remember, in Newton's first law of motion, if an object is at rest, it will remain at rest. And if an object is in motion, it will remain in uniform motion, unless an unbalanced force acts on it, okay?
Right, got it. What about the second law?
Oh, in Newton's second law of motion, talks about
Well, as I recall in the broadcast of our teacher's play, it stated that the greater the mass of an object, the more the force it will take to accelerate the object. So it's like how fast an object can move.
exactly. For example, the harder you throw or kick the ball, the farther it goes.
Now I know. So how about the law of motion then?
I didn't know it yet. I only know about the first and second law. I'm kinda curious about the third law.
That's all for today.
Wait, officer, what have we just discussed earlier?
Oh, it's all about Newton's law.
Really? Really? Can you teach us about the last law of motion, bro? My friend here really need to know for their task.
We can, if you have some time.
Yes, we have plenty of time.
Yeah.
Shall we begin?
Yes.
Since you already know the first and second law of motion, we're gonna go jump to the third law. Newton's third law of motion is all about action and reaction law. So what is action and reaction law?
Newton's third law of motion or so-called the action and reaction law, states that when the two bodies interact, they apply force to one another that are equal in magnitude and opposite in direction. Also, the Newton's third law of motion states that for every action, there is an equal and opposite reaction. Simply put, it means that every force can be undone. Mathematically, it means that for every vector, there is another vector in direction and equal magnitude.
For example, a block on the floor exerts a downward force on the floor equal to its weight. In turn, the floor exerts an upward force on the block equal in magnitude to the block's weight. The force exerted by the floor is called a normal force.
Wait, Professor, what is normal force?
Normal force? Oh, normal force is the force that surfaces exert to prevent solid objects from passing through each other. Normal force is a contact force. If two surfaces are not in contact, they can't exert a normal force on each other.
Okay.
Here is another example. A bulb hanging at the end of the string pulls downward with its weight. In turn, the strings pulls it up with an equal strong but opposite force called tension.
And Professor, what is tension force?
Good question. The tension force is defined as the force that is transmitted through a rope, string, or wire when pulled by forces from opposite sides. The tension force is directed over the length of the wire and pulls the energy equally on the bodies at the ends. Also, the tension force is the force generated when the load is applied at once or more ends of the material in a directional way, normally to the cross-section of the material. The tension force is often given as the pulling force.
Well, can you give us a last example?
Yeah, we really want to know more.
Okay, then this is the last, okay? Now, listen carefully. Just like the two of you are sitting right in the chair. So, the person sitting on the chair exerts a downward force equal to his weight. In turn, the chair exerts an upward force on the person equal to the magnitude of the person's weight. The upward force exerted by the chair is called a normal force. The action is sitting on the chair. The opposite reaction is the upward force of the chair. The upward and downward force is equal in magnitude. This is in accordance to what the law of action and reaction states.
Now did you get it?
Yes, Professor.
Yeah, now I know what the third law is. I can do my performance task now. Thanks, Professor. You're the best.
Thanks, bro.